got a feeling. I got a feeling.
Hello everyone, this is Bhargavi and they are my friends.
Hello, I am Durgarao.
Hi, I am Moses Pal.
We are going to show you how to conduct an experiment to determine the field density by using sand replacement. Field density can be determined by various methods and popular among them being core cutter method and sand replacement method. Generally, core cutter method is conducted on moist and clay type of soils, whereas the sand replacement method can be conducted on any type of soils. Apparatus required for conducting the experiment includes sand pouring cylinder, calibrating can, metallic tray with circular hole, 1 mm ISC, 600 microns ISC, sufficient clean uniform sand, smooth surface glass, sensitive electronic balance, digging bar, shovel, flat trimming edge, moisture cans, hot air oven.
In the sand pouring cylinder, it has a circular hole at its center, which can be operated by using this shutter. It consists of a conical portion at its bottom. Here we can observe the hole in the conical portion. Let's go. Here is the equipment we need for the experiment. These are 1 mm and 600 micron Indian standard sieves. It's a digging bar, moisture can for determination of moisture content. Here is a metallic tray with a circular hole. It is a cylindrical calibrating container. A metal dish, sufficient clean sand, a smooth surfaced glass plate, a sand pouring cylinder with a conical portion at its bottom. It has a shutter to operate the circular hole. Now we have to sieve the sand using 1 mm and 600 micron sieves. After sieving sand, remove the residue retained on 1 mm sieve and use the sand retained on 600 microns. It is the sieved sand. We are going to use this sand for the experiment. Fill the sand pouring cylinder with sand. Level the surface. Fill the sand pouring cylinder by leaving 10 mm from its top. Now weigh the filled sand pouring cylinder. Its weight is 6200 grams. Now we are going to find the weight of the sand in the conical portion. Place the sand pouring cylinder on the glass plate. Gently release the shutter and allow the sand to run out. until no further movement takes place. Close the shutter and remove the sand pouring cylinder carefully. We can observe the sand from the conical portion. Now weigh the sand pouring cylinder with remaining sand. We have to find the weight of the sand in the conical portion. We want to know the density of the sand. So we use this calibrating can to find the density of the sand. Keep the sand pouring cylinder over the calibrating can and open the shutter and allow the sand to run out from sand pouring cylinder to calibrating can till the calibrating can is filled. Now close the shutter. Now you are going to trim the conical portion using the trimming edge. Make the surface plane. Now weigh the calibrating can with filled sand. Its weight is 2500 grams. As we know the weight and volume of the sand, we can find the density of the sand. Again fill the sand pouring cylinder with the sieved sand. Its weight is 6200 grams. Now weigh the metallic tray. Its weight is 1339 grams. Now it's time to go to the field. Collect the equipment. Metallic tray with circular hole, sand pouring cylinder and a digging bar.
Hello guys, now we are in the field. Expose an area of about 450 mm square on the soil surface where the test is to be performed. Trim the surface. Level it by using a tool. Now we have to place the metallic tray on the cleaned surface. Excavate a hole in the soil using the digging bar. Excavate up to a depth of 15 centimeters. And collect the excavated soil into the tray. It's around 15 centimeters deep. Here you can see the circular hole excavated. After excavating a circular hole of almost 15 centimeters deep, place the sand pouring cylinder concentrically over the excavated hole. Open the shutter and allow the sand to run out into the hole until no further movement of sand takes place in the cylinder. Now close the shutter, remove the cylinder from excavated hole. We can see the sand filling the pit with a conical shape. Here is the soil excavated from the pit. Its weight is 2400 grams. Collect the soil sample into the moisture can. Now weigh the sand pouring cylinder with remaining sand. Its weight is 3 kg. Now weigh this wet sample using this sensitive balance. Its weight is 13.29 grams. Put this moisture can in the oven. After 24 hours, we have to take out the moisture can from this oven. Now weigh the dry soil sample to determine the moisture content. Calculations required to determine the field density of soil. Initially, record the weight of the sand pouring cylinder as W1. After filling the sand pouring cylinder with sand, weigh it and record as W2. Weight of sand pouring cylinder plus remaining sand after filling the conical portion, say it as W3. We can get the weight of sand inside the conical portion as WSICP by deducting W3 from W2. Note the internal diameter and height of the calibrating can to calculate the volume of the calibrating can as VCC. Take the empty weight of calibrating can and say it as WCC. Note the weight of sand plus calibrating cylinder, say it as WCCS. Now calculate the weight of the sand in calibrating cylinder by deducting WCC from WCCS. Now the density of sand is given by weight of sand in calibrating cylinder by volume of calibrating cylinder. Here gamma sand is the density. Note the empty weight of tray WET. Again, weight of sand and sand pouring cylinder as W4 and record the weight of tray with excavated soil. And weight of excavated soil is equals to WTES minus WET. Take the weight of sand pouring cylinder after filling the pit as W5. Weight of sand in the pit is W4 minus W5 minus WSICP. Volume of the pit can be obtained by dividing the weight of sand inside the pit with density of sand. Density of the soil is calculated by dividing the weight of excavated soil with volume of the pit. The dry density can be found if we know the moisture content.
Okay friends, we hope you understand this experiment. Thank you.